Hey, y'all, let's cover lecture 1.1. Um, I don't know if you printed off prior to this, but I originally had other questions prior to order of operations, but it's not as important as this piece right here. So in fact, I'm not even going to cover it. It's not going to be on the exam. The most important part for this section is I don't typically cover 1.1 and 1.2, but because of foundation issues with students, I found that we really need to hunker down and get a good handle on chapter 1. So 1.1 and 1.2 is going to be included in this class now, unfortunately. So let's just work through this, take notes, ask me any questions you have, either in class, shoot me an email, come to office hours, whatever you need, just to make sure that if there's anything on this, that my lecture that I'm giving you that you don't understand, that you get a good handle on it before quizzes and exams. All right, so let's talk about PEMDAS, the order of operations. PEMDAS is just the acronym for you have to do parentheses first, exponents second, multiplication and division. This is where the struggle happens. It's not multiplication first, then division. It's whoever comes on the problem from left to right. You always work your problem from left to right, with the exception of parentheses and exponents. You do them first. Anything with a parenthesis could be a bracket, a parenthesis, those cute little squiggly things. It could be absolute value, anything parenthesis related. Then the next is your exponents, which would be something like x cubed, squaring it, anything like that, anything having to do with exponents. And then finally, multiplication division, as you see the problem coming from left to right. All right. The next is addition and subtraction. It has the same rule as multiplication and division. You do not do addition first and subtraction. You work the problem from left to right. All right, so let's do some order of operations here. We've got 3 times 2 squared minus 4 times 6 plus 2. So we have to do parentheses first. I'm going to come up here and do this. I don't have a lot of space because I was going to do this on the board. So 3 times 2 is 6. I'm not doing my square yet. Minus 4, 6 plus 2 is 8. 6 squared is 36. Minus 4 times 8, because that's the exponent. And then now we can do minus 4 times 8, which is 32. So our answer is 4. All right. Any questions about that? Let me know. 5 squared minus 4 over 7 minus square root of 11 minus 2. So we need to do what's underneath the radical first. It falls into the parentheses portion because it's contained. So I'm not going to rewrite these because it's going to make me crazy if I have to do that. And it's going to make you crazy too if I do every single step. So please bear with me. I'm going to go ahead and do the 5 squared, 25 minus 4 over 7. I'm not doing anything else because it's not tied to the 11 minus 2. Minus the square root, 11 minus 2 is 9. So now we have 25 minus 4 over 7 minus the square root of 9. I should rewrite the 25 minus 4 over 7. I'm not, because it's not attached to that square root of 9. So I'm going to go ahead and subtract. Now, I know division comes before subtraction, but these are attached, 25 minus 4. So you have to go ahead and subtract these before you divide them. You can't go 25 over 7 or 4 over 7. You don't want to do that. So 21 over 7 minus the square root of 9, which is 3. 21 over 7 is just 3. Minus 3 is 0. Okay, let's look at the next one. 6 minus 5 minus 8. I'm going to want to do that first. Plus 3 times 4 minus 1. Again, parentheses first. So 6 minus the absolute value of 5 minus 8 is negative 3. Plus 3 times 4 minus 1, which is 3. All right, so now we have 6 minus the absolute value of 3. If you've never seen an absolute, you've all seen absolute value. Absolute value, just you might have just forgot. It's just the distance between 0 and that number. So it always, always, always has to be positive. So between 0 and negative 3 is 3. So 6 minus 3 plus 3 times 3 is 9. 6 minus 3 is 3 plus 9 is 12. Okay. look at the next one. 14 minus 3 times 2 over 2 times 5 minus 3 squared. Well, parentheses, we don't have any. Exponents would be next. So that 3 squared is going to be a 9. I would do that. And then next is just left to right multiplication division. So you are not going to go 14 minus 3. That would be no bueno. So you're going to leave the subtraction alone, and you're going to go ahead and do your multiplication first. Over 2 times 5 minus 9. 2 times 5 is 10 minus 9. Now we can do our subtraction. 14 minus 6 is 8. 10 minus 9 is 1. And then now divide, it's just 8. Okay. Looked a little crazy at first. The next one is 7 times 5 times 3 minus 2 times 6 minus 3 minus 4 squared plus 1. Lord have mercy. Well, here's our exponent. We've got a lot of parentheses happening. So let's see if I can clean this up. 7 times 15, don't have my calculator, this is gonna be fun, minus 2 times, well, we need to do the 6 minus 3, which is 3, minus, I'm gonna go ahead and do the 4 square, which is 16, plus 1. All right, now I've got 7 times 15. Well, I'm supposed to do the parentheses, but I'm gonna go ahead and do these since they're a separate term. So bear with me. 105 minus 2 times 3 minus 16 is negative 13 plus 1. Now I'm going to multiply the negative 2 and the negative 13, which is positive 26. And now we just add everything. So 105, 26, and 1, 12, 3, so it's 132. Okay. Using properties of real numbers. Again, it's just, I don't need you to know what the property is. I need you to be able to use it. 3 times 6 is 18. 3 times 4 is 12. 18 plus 12 is 30. 5 plus 8 plus negative 8. Well, 8 plus 5, 8, 9, 10, 11, 12, 13. Plus negative 8 makes that a negative 8. Positive times a negative is a negative. 8, 9, 10, 11, 12, 13 is 5. Please do not be afraid to use your hands when calculating. If you don't have a calculator, the Chinese did some really cool stuff with using different digits and stuff to calculate on the hand. Use every tool you have, use your resources. That's what I always say. Doesn't make you look stupid, makes you look freaking brilliant. 15 plus 9. 9, 10, 11, 12, 13, 9, 10, 11, 12, 13, 14. So that's 24. 6 minus 24 would be negative 18. Now this is where everyone freaks out on me. When you're multiplying fractions, you multiply straight across. Swear, everyone and their dog wants to do cross multiplication, and there's only one time you can use it. I will discuss it in class, but it's just best not to get in the habit of using any kind of cross multiplication because it's going to confuse you. So when you're dealing with something like this, you're just multiplying straight across. In this case, they want to do the parentheses first, so that's 4 sevenths times 2 times 7 is 14 over 12. I could have reduced first, which is what I probably would have wanted to do, but I didn't. And then next, you're going to multiply straight across. Before I do that, because you're going to want to answer in a reduced form, I want to reduce this 14 over 12 fraction first. So I'm going to leave the 4 sevenths for now, and I'm going to reduce the 14 over 12 by 2 and get 7 over 6. Okay. Now I'm going to multiply straight across. Oh, wait a minute. This is the same thing as 4 times 7 over 7 times 6. These reduce. So that leaves me with 4 sixths, which reduces even more by 2. 2 goes into 4 2 times, and 2 goes into 6 3 times. Okay, last one. Just a little bit of decimal here. I have to use my calculator. I don't have a calculator. All right, so the next, oh, it's added subtraction. So it's 100 times 0.75 plus negative 2.38. This is just a negative. Okay, I don't know why they do that. But 2.38 is negative, and then 0.75, so negative 2.38 plus 0.75. I'm going to subtract these real quick. 6, 1, borrow, negative. Okay, you can use your calculator. I do not have mine. 1.63, so 0.75 minus 2.38 is negative 1.63 times 100 is negative 163. All right, describing algebraic expressions. List the constants and variables of each algebraic expression. Okay, constants cannot change. They are constant. Variables can change. They're variable. Variables are going to be your x's, your y's, your r's, anything that can change. So your variables, constant. In this case, x is your variable, 5 is your constant. In this case, the 4/3 is constant because it's a fraction, it's a number. Pi is a number, 22/7 or 3.14, continuing forever. So pi is a constant. R is a variable, okay? For the next one, square root of 2m cubed n squared, 2 is your constant, m is a variable, and n is a variable. All right. Evaluating expression, algebraic expression at different values. So evaluate this expression for each value of x. So we're just going to plug in each of these numbers into the x and solve the expression. So the first one is 0. 2 times 0 minus 7 is 0 minus 7, which is negative 7. The next one is 2 times 1 minus 7, which is 2 minus 7, negative 5. 2 times 1/2 minus 7. 2 times 1/2 is 1, because if you think of this as over 1, 2 times 1 is 2. Maybe I'll do that. 2 times 1 is 2. 1 times 2 is 2, minus 7. This reduces to 1. And 1 minus 7 is negative 6. If you need help with fractions, please let me know, or please reach out to the Learning Center for a tutor. You need to get comfortable with fractions. If you need a website to work with it, please let me know. I'd be happy to do so. So 2 times negative 4 minus 7 is negative 8 minus 7, which is negative 15. All right. Evaluate each expression for the given values. So x plus 5 when x is negative 5. So these are just plugging in for individual expressions. An expression does not have an equal sign. An equation does. So you can't solve for x unless there's an equal sign. So we're not solving for anything here other than finding values of the expression. All right, so this is just taking the negative 5, plugging in for x. It's negative 5 plus 5, which is 0. The next one, plugging in 10 for t. So 10 divided by 2 times, there's another 10, minus 1. That says 10 over 2 times 10 is 20. 10 over 19, and I think I'm done. That's as good as it's going to get. 4/3 pi r cubed. So we're going to plug in 5 for r. So 4/3 pi, and then 5 cubed. 5 cubed is 125. 5 times 5 is 25 times 5 is 125. So that's 4/3 pi times 125. Probably the last thing I would do here, set divisible by 3. Yes, it is. So that's the first thing I would look at, see if I can reduce this 3 and this 125. Because when you multiply straight across, you're going to get 4 times pi times 125, all that over 3. That's what this is equal to. So I'm already starting to think about what can I reduce. And I know 3 goes into 125, but nope. No, it doesn't, because 3 goes into 12 4 times. That leaves you a 5, and nope, it doesn't. So we're just going to multiply this out. 125 times 4, 8 and 10, 5. So that's 500 over 3. 500 pi over 3. Let me make sure that 3 doesn't go to 500. Just to verify. 3 goes in 20. 6 times. Oh, it's going to give you the same thing. Yeah, it's just going to be a continuous. It's not a exact number. All right, so a plus ab plus b. We're going to plug in a 11 for a and negative 8 for b. A is 11 plus 11 times -8 minus plus -8. I'm just plugging in for now. All right, so this gives me 11, just going left to right. This is the -88, and this is -8. And then this gives us 11 minus 88 is -77 minus 8. -77 minus 8, 15, -85. You could just plug this into your calculator, 11 minus 88 minus 8 to get that. All right, the last one is square root of 2m cubed n squared. M is 2, n is 3. So that gives us the square root of 2 times 2 cubed times 3 squared. 2 times 2 cubed is 8. 3 cubed is 9. 2 times 8 is 16. How should I go the other way? 8 times 9 is 72 times 2. Why did I do that? 2 times 2 is 4, 14. So 144. Okay. That's just 12. Awesome. Okay. Last page. Using a formula, a right circular cylinder with radius r and height h has a surface area S in square units. Anytime you're measuring area, it has to be in square units. Given by the formula, the surface area is equal to 2 pi r, which is the circle, times r plus h. So I find the surface area of a cylinder with radius 6 inches and a height 9 inches. Leave the answer in terms of pi. So you're not going to use your pi on your calculator. It's literally going to have pi in your answer. So we're going to take the surface area, 2 pi, we have a radius of 6. So r is 6 inches, height is 9 inches. I just like to have this here so that I don't have to keep referring back to the problem. So 2 pi 6 times 6 plus 9. The surface area is 2 pi, well, I should multiply these. It should be 12 times, parentheses, it's 15. 15 times 12 is 180 pi. There you go. All right, simplify each algebraic expression. Well, we have to combine like terms. We cannot combine anything unless they are like terms. So unless it has just an x, we can't combine it. So 3x and x is 4x. -2y and -3y is -5y. And then we've got -7 kicked out here to the side. That's combining like terms or simplifying. 2r minus 5 times 3 minus r plus 4. I'm going to distribute that 5. This is something students really mess up hard on every single semester, is they multiply that -5 times 3 and they totally ignore distributing. This is a parenthesis. You have to carry that 5 to everybody in that parenthesis. Don't just pick your favorites here. So we've got 2r minus 15. That's -5 times 3. And then -5 times -r is +5r, and then plus 4. Now we can simplify. 2r and 5r is 7r. -15 and 4 is -11. There you go. All right, 4t minus 5/4s minus 2/3 t plus 2s. Same thing here. This is the one thing I see students every single semester struggle with, is this negative has to be distributed over both parentheses here, both pieces in both terms in that parentheses. So we've got 4t, I'm not changing anything inside the first one, minus 5/4 s. Now I'm going to change everything in here, change their signs to -2/3 t minus 2s. Now I can combine my like terms. 4t minus 2/3 t. Now I'm going to do this the way I learned it in school, finding common denominators. When you're adding and subtracting fractions, you have to have a common denominator to do that. So our common denominator is going to be 3. In order to have 4/3, we've got to go, okay, this is 4/1. And we want our denominator to be 3. Let me come over here and do it a little bit bigger. 4/1, 2/3. and they both have t, so I'm going to leave that part out for the confusion aspect. All right. This one stays 2/3. This one, we need to have a 3 in the denominator for them to combine. So because it's a 1, we can go times 3 is 3. But what we do to the denominator, we have to do to the numerator. And that's how we get our common denominator. 12 minus 2 is 10 over 3. So that's 10 over 3 t. I'm just trying to find our final answer. And then we've got negative 5/4 s minus 2s. So negative 5/4 minus 2. This is over 1. So negative 5/4. We want a 4 in the denominator so we can combine our like terms. So times 4 is negative 8. Negative 5 minus 8, you add them. 8, 9, 10, 11, 12, 13. So it's negative 13 over 4 minus 13 over 4s. Fractions are the hardest part for students, unfortunately, which makes it rough because you can't learn the new terms and the new methods that we're doing in math without having a good handle on these basic math applications as fractions. So if you're struggling with fractions, you're going to struggle this semester. Get a good handle on it. Work with me. I'm happy to do so. Okay. Let's combine like terms. 2mn, 5m, 3mn, and n. So these two can combine, and it looks like that's it. 5mn minus 5m plus n is your answer. All right, that's it for lesson 1.1. I will see you on 1.2. Have a great day and let me know if you have any questions.